Hello and welcome back to another Orange Coast College mathematics video. Uh, in this video, we are going to talk about another way to calculate values of trig functions. Now, this video is interesting because every problem that is in this video, you actually should be able to do if you're comfortable with the last video. We're just showing an alternate way to think about and calculate these trig values. So we have something here called the unit circle. And what's interesting about the unit circle is that it sort of stores those special right triangle information that you had in the last video. So for example, if I look at this ordered pair, this xy point right here, if I drop the altitude of this, and I recognize this is 1/2, this is radical 3 over 2, and a radius of 1, that's just one of those special right triangles, a 30, 60, 90 triangle, divided by 2 on all sides. But it's the same ratio. And so we're really just creating a table, if you will, of a bunch of values that are easy to reference. Now, in your class, you're going to need to be able to evaluate these without, being given the unit circle. So some students prefer to memorize the unit circle. Some students like to use the method in the last video. Some students like to do a hybrid version where they kind of partially think of what the unit circle looks like in their head to determine which of these sort of common values, 1/2, radical 3 over 2, radical 2 over 2, were being used. However you choose to do it is fine. Again, this video is just an alternate way of coming up with the same answers. So let's do some examples to see what it is we're talking about here. So first things first, we're asked to find the sine of 135 degrees. So let's look at this unit circle. 135 degrees ends up right here. So this is the x and y coordinate that we're looking at. Now we know from the last video that the sine of 135 degrees should be equal to the opposite over the hypotenuse, or in other words, the y value over the radius, like we saw in the last video. Now, we say this is a unit circle because every radius is going to be 1. So r is always 1 in these problems. So what is this going to be equal to? This will be equal to the y value, which is positive radical 2 over 2, divided by 1. Of course, dividing by 1 is always going to just leave you with the same thing you started with. So my answer is radical 2 over 2 to this problem. And so because the radius is always going to be 1, it turns out that sine of any angle is just going to be the y value, and cosine of theta is just going to be the x value in the unit circle, because when we're dividing by r, we're just dividing by 1. So let's go ahead and continue. The tangent of 270 degrees. 270 degrees is down here. We know tangent of 70 degrees is equal to the y value over the x value. In this problem, the y value is -1. The x value is 0. And oh, look at that, we're dividing by 0. Well, what happens when you divide by 0? You can't. Dividing by 0 is not a defined operation, so we're just going to say that this particular trig value is undefined. Continuing forward. And if you're feeling comfortable with what I'm doing, as always, feel free to pause the video and try one or two of these yourself before I try it. Even if you don't get the correct answer, that experience of trying it on your own and then seeing how it's actually done is a nice way to learn, rather than just waiting for me to do it. So this one says the secant of -120 degrees. Going back up to this picture here for a second, if we've got -120 degrees, -120 degrees starts this way and ends up here. We go 90 in this direction plus an additional 30 is a -120 degrees. So we're looking at this coordinate. Well, secant is the reciprocal of cosine. So instead of being x over r, it is r over x. The radius in the unit circle is always 1, and the x value is going to be -1/2 in this problem. And so the reciprocal of that, this 1 divided by -1/2, which is, of course, when you divide by fractions, it's the same thing as multiplying by the reciprocal, and I just get negative 2. This next problem is a little bit interesting because we're taking the cosine of something larger than 360. Remember that full rotation of the circle is 360 degrees. So if I subtract off 360 degrees, I'm going to get a remainder of 150 degrees, which means I'm going around the unit circle 360 and then an additional 150, which takes me right here, 30 less than another 180. Here's the 150 degrees, right? So I'm using this ordered pair. Well, the cosine of 510 degrees is, as it's been, is going to be x over r, or in this case, just x because we're in the unit circle, because r is just 1. And that x value is just going to be negative radical 3 over 2. And so our answer is negative radical 3 over 2. All right, let's proceed forward. This one's interesting because it's sort of asking us to go backwards. This is asking us to solve the equation on the interval between 0 and 360 degrees. This bracket means including 0, but not including 360. So basically, because the unit circle repeats and we can keep going around and around and around forever, we could get infinitely many different angles that give us the same trig value, but we're restricting ourselves between 0 and 360. So here I'm asking for the cosine of theta being negative radical 2 over 2. We know that the cosine of theta is negative radical 2 over 2 when the x value is negative radical 2 over 2. So we just have to go up here and ask, when is the x value negative radical 2 over 2? Well, it's going to be in the second and third quadrant because that's when the x value is negative, and I'm going to see that it's here and here. So I'm looking at 135 degrees and 225 degrees as our answer. Now you might say, well, wait, doesn't negative 135 degrees work because I end up at the same position? It would give me that same trig value, but again, in this problem, I'm only asking between 0 and 360 degrees. So our answers are going to simply be that 135 degrees along with 225 degrees is our set of our two solutions. For these next problems, we are doing exactly the same thing. We're just now using radians. So for example, if I ask for the sine of 7 pi over 4, we know that that's going to be the y value. I simply need to find where 7 pi over 4 is. Oh, it's there, and the y value is radical 2 over 2. So my answer is radical 2 over 2. For the tangent of 4 pi over 3, we know that is going to be the y value over the x value. Let's go ahead and find that for 4 pi over 3. 4 pi over 3 is a little bit more than pi, so we'll be looking down here. It's right here in this position. And I'm going to get a y value of negative radical 3 over 2 and an x value of negative 1/2. And so this is going to be equal to negative radical 3 over 2 over negative 1/2. And now we just need to do that fractional division. Well, when we divide by a fraction, is the same thing as multiplying by the reciprocal. This is negative radical 3 over 2 times negative 2 over 1. Those 2's cancel, the negatives cancel, and I get radical 3 over 1, which is just radical 3. For this next problem, we could, again, look up the value in the unit circle just as we have been doing. I'm going to explain it slightly differently just to show a different way of thinking about it, sort of what I mean when I said before about an abridged version, kind of using the unit circle, but also kind of using the knowledge of special right triangles. So this is how I would think about it in my head. But you could do it the exact same way we just did. We've been doing this whole video. 5 pi over 6 I know is a little bit less than pi over 6. I know I'm right about here. Because this is the same thing as 150 degrees, this is simply put going to be comprised of a triangle looking something like this. Now, in my head, I know the secant comes from the x value, specifically the reciprocal of the x value. Now, there's only so many values in the unit circle. Because we're dealing with 30, 60, 90 triangle here, I'm thinking, okay, the x value is going to be either 1/2 or radical 3 over 2. It's going to be one of those two. Because I'm this side here, the x side, is the longer side than the y value, I know that this is going to be the radical 3 over 2 because that's larger than 1/2, or specifically negative because we're moving to the left. So since this is just 1, or I could say r over the x value, of course, r is 1. This is 1 over negative radical 3 over 2, or in other words, the reciprocal, which is negative 2 over root 3. We can rationalize the denominator, multiply by a radical 3 over radical 3, and get negative 2 radical 3 over 3 as my final answer. So that's sort of a sort of geometric, kind of using the knowledge of the unit circle, but not just specifically looking at it way of doing it. That's not right for every student. You might choose to memorize the unit circle. You might choose to just use fully special right triangles every time like we did in the last video. It really just depends on what works best for you. Okay, lastly in this one, we've got negative pi over 3. I'll go back to this unit circle here. Negative pi over 3 means I'm moving in this direction. So instead of being up here at pi over 3, I'm down here at negative pi over 3, which is coterminal with 5 pi over 3. So our ordered pair is 1/2 comma negative radical 3 over 2. Because this is cosecant, this is the reciprocal of sine, this is the same thing as r over the y value, which is, of course, 1 over the y value, which we saw up there was negative radical 3 over 2. And so we'll take the reciprocal of that, which is negative 2 over radical 3, which, of course, is exactly the same answer for part C. So we know when we rationalize that, we get negative 2 radical 3 over 3. And that'll take us to this last problem, just as we did above. Let's solve an equation where we know the trig value and we're trying to find the angle. This is asking for when the cosecant of x is negative 2. Now be careful, this x doesn't refer to like the x coordinate up top. It's just some input variable here. But we're really asking, when is cosecant negative 2? Well, what I like to do, it's easier for me to think of these in terms of sines and cosines. So I'm going to recognize first that this is the same thing as the sine of x being negative 1/2, the reciprocal of that negative 2. We're getting negative values of sine, which happens in the third and fourth quadrant here. So really, I'm just asking here, where in these two quadrants do I get a sine value of negative 1/2? Well, that's going to be the y value, right? And here's a y value of negative 1/2, and here's a y value of negative 1/2. So in radians, my answers are going to be 7 pi over 6 and 11 pi over 6. And so we get that x is, well, I guess you don't really want to say x is equal to a set, but the set of solutions is 7 pi over 6 and 11 pi over 6. And that will be the two solutions between 0 and 2 pi that give us this cosecant video. Thank you for watching this video, and feel free to move on to trigonometry 3.